Okay, here we go with the last seventh video in the CR standard, which stands for creating and reasoning with equations. This is one of the toughest problems we did last semester, wind distance problem of a rational equation. Now what we've got here is a motorized glider that flies about 70 miles an hour in calm wind. You fly at 150 miles out and 150 miles back, and the total trip takes, I made a mistake during fourth period, we're going to change that to 4.5 hours. We need to do the math and find out what was the wind speed. Now, the thing about this rational equation is it's derived from the distance equation, which is distance equals rate times time. I mean, think about it. If you're driving 50 miles an hour and you drive for 4 hours, that's going to give you 200 miles, right? And you can also modify this and solve for certain variables. Like if I solve for time, if I divide by r on both sides, those are going to cancel out. I get distance over rate equals time, which is what I have here. So I'm going to fly 150 miles, and the glider flies at 70 miles an hour in calm wind. Let's say the going to trip was with the wind, and the coming back trip was against the wind. So my rate going to there was with the wind, so the wind adds to my speed. And coming back, the wind is against me, so the wind subtracts from my speed. And like I said, from the problem I have written down, it equals 4.5 hours. Now, one of the most beautiful things about solving by using the least common denominator is when you multiply the entire equation by the least common denominator, it's going to wipe out everything in denominators, and you're just going to be left with a single line equation, which is why multiplying by the LCD is so awesome. In this case, the LCD is these two terms because this one's over 1. So we have 70 plus W and 70 minus W. Okay, we're going to multiply every term by that. If I multiply this by this over here, the plus w's cancel out, and I just get 150 70 minus w. I'm adding 150 times what cancels out from here. It's the minus w's. So you got 70 plus w, and then everything is on the right hand side. 70 plus w and 70 minus w. Now we're going to take care of that right hand side first. By the way, this is what the factoring of a difference of two squares looks like. Remember, if you have a squared plus b squared, if you factor that, difference of squares, it's a plus b, a minus b. We're going to do that in reverse. If I have a plus b and a minus b, multiply them together, it's just, I'm sorry, it's supposed to be a minus right there. It's going to be 70 squared, which is 4,900, and minus w squared. Still have to multiply that times 4.5. Over here, we've got 150 times 70, which I think is 10,500 if I remember correctly. Yep, 10,500, and then minus 150W, and we've got plus 10,500, and then plus 150W. Okay, so that's the equation so far. The 150Ws are going to cancel out. Okay, so 10,500 twice, I do believe, is 21,000. And 4.5 times 4,900, 22,550. And we've got minus 4.5 W squared. Now we're going to subtract, divide by negative 4.5, and take square root. Okay? So 21,000 minus 22,050, negative 1050. Negative 4.5 W squared. Let's divide this by negative 4.5. So about 233 repeating. Let's leave it in there. And we're going to be taking the square root of both sides. So square root of that answer gives me about 15.3. Now remember, it's plus or minus 15.3 miles per hour. But in our case, we're just going to simplify and go with the principal square root. So the wind was about 15.3 miles an hour. That's it.